Conceptually, the idea of a reflection isn't really that complicated, and so students usually do very well when working with them graphically. However, when trying to transform equations that have been reflected, it's a bit more nuanced and sometimes little errors can be made. Let's have a look here at the function f of x equals x squared plus 8x plus 12, so another quadratic function, and transform it in one case with a vertical reflection, so over the x-axis, and in the other through a horizontal reflection, and see how their equations turn out differently. So when we reflect over the line y equals 0, which is the x-axis, we write the transformation in terms of f as negative f of x. This means that if x squared plus 8x plus 12 is equal to f of x, since we made f of x negative, we'll be making all of this negative. So we put a negative sign out in front of some brackets and then distribute it through. The other way to think of this is that we made a substitution of y with negative y, a replacement of y with negative y, and then multiplied through by negative 1, giving us that same result. If, however, our reflection is over the line x equals 0, which is the y-axis, in this case, we write the transformed function in terms of f of x as y equals f of negative x, because it is the x-coordinate that we're making negative. So now, when we want to write the equation in terms of x, we have to replace each instance of x with negative x. Be very careful when you do this. It's so important those negative x's are bracketed. In the case of the 8x term, it will change from positive to negative. But in the case of the x squared term, what was originally x squared, because it is a negative x squared, the negative sign will be effectively canceled out as negative x times negative x goes back to being positive. This gives us a final form of y equals positive x squared minus 8x plus 12. Now that we've determined our transformed equations, it's worth putting them into our graphing calculator to confirm that we've correctly associated them with the vertical or horizontal reflection. You can see in the left case that when I put negative out front of a bracketed x squared plus 8x plus 12, I do in fact show the vertical reflection. And when I replace each instance of x with negative x, as in the right case, we do get that reflection over the y-axis. This is a continuation of the previous slide. In the left graph, you should draw the transformed image of the parabola after being reflected in the x-axis. And in the right graph, you should draw the transformed image after being reflected in the y-axis. Do this, then try to determine the coordinates of the invariant point or points, as well as the domain and the range for your transformed graph. Notice in this left graph that under the reflection in the x-axis, our mapping rule shows that xy becomes x and negative y. So we've changed the sign of every y coordinate. This means that points on the x-axis did not change. So our x-intercepts that happened at negative 6 and negative 2 were unchanged. All parabolas, whether opening upward or downward, will have a domain of all real numbers. The range is limited by the maximum height. So in the case of the green graph, our highest height is 4. So our range will be all values of y such that y is less than or equal to 4 and is an element of the real numbers. In the right case, we see that our mapping rule is that xy becomes negative xy. So all the x coordinates have been changed from positive to negative, or in this case, negative to positive. The only invariant point here will be our y-intercept that happened at 0 and 12. Again, the domain of the transformed function, because it's still a parabola, will be all real numbers. This means there's been no change to the domain after the transformation. Also, because our transformation was a horizontal one, which is to say the horizontal reflection in the y-axis, we haven't changed the range from the original graph. So where it originally was all values of y greater than or equal to -4, it is still that same range.